Gracias por estar aquí con nosotros. Estamos en una plática que se llama Construyendo videojuegos multiplataforma para la nube. Nuestro ponente es Schalk, como lo ven aquí en la biografía. Él es Developer Advocate en Google, incorpora a las comunidades desarrolladoras de la nube, tanto con el motor de Google App y otras tecnologías de Google NUBE. Chris se unió a Google en el 2007 y ha trabajado en varias tecnologías de Google, incluyendo Open Social Maps y APIs. Antes de Google, Chris era gerente principal de producto en Oracle en el grupo de desarrolladores de herramientas y coautor de Java Server Faces de Complete Reference. Los dejo con Chris. Muchísimas gracias.
Hola. Hola. Buenas tardes. Voy a hablar en inglés. Estoy un poco cansado. So I hope it's okay if I speak in English. I'm going to be talking today actually about a very fun topic. It's how to do video games with a really cool open source technology. So construyendo videojuegos multiplataforma para la nube. So just as an example, I actually work with literally sitting next to me, the main guy who's been working on a very popular game on Chrome. So are you guys familiar with Angry Birds? So I think so, right? No? Never heard of it? Well, it's really neat. It's got a little bit, no. So Angry Birds, it's available on Chrome. I'm sure you know. So I actually sit next to the main guy working on that. And by sitting next to him, I was able to get introduced to a really fun video game platform, which you can build video games for multiple environments. So not just desktop or Flash or web, but all of them are combined. And it's very simple. It's very easy to learn. And so the presentation I have here is relatively short, just explaining the key concepts and where to go to get started. And then I think, you know, within a day or so, if you're interested, you could be doing exactly what I'm doing, because what I'm doing is not very complex. It's actually fairly straightforward. Okay? So let's start with a demo, shall we? Let's go ahead and pop open. Yes, you guessed it. Angry Birds. So this is using the same technology that I'm going to show you how to work with. And you'll be surprised how easy it is to work with. So straightforward. Hopefully everyone's seen the game. I think one of the coolest thing about Angry Birds is the physics engine, because you get the angles just right, and you can observe the interactions between all of the pieces here. And that's really cool because, as I'll explain later, it's very easy to use this physics engine within this framework, and you can have your own game do these types of interactions relatively straightforward. Darn. When I practiced, I got it in one shot. Now I have to do 3. So anyway, oh, come on. All right, one more try, and then I'll finish up. But you get the idea. Boom. Oh, I'm not very good, apparently. I'm going to be here all day. Let's see. Wow. The last time I did it in one shot. So anyway. All right, one more time. I'll just do it one more time. Sorry. Give it one more shot. Okay, here we go. All right. Boom. Oh. I could get that big thing to fall down. Anyway. Okay, one more time. See, it's very addictive, I know. So come back if you want, maybe 10 minutes. It's just, Oh, this is not good. Not good at all. Okay, one last time. Okay. Oh, okay. Wow, there we go. Finally. No. Not very good. Oh, well. So, I should have done much better. Wow. No, okay, let's move on. Let's talk about the technology. How is that stuff built? It's actually very cool. If I can find my presentation. There we go. So, Angry Birds was built using a very fun technology called Foreplay. So Foreplay is a Google Web Toolkit abstraction layer for games. It's actually a very small API, The API, you can learn it relatively easy. And the main, I think, value that 4Play has is that you can build cross-platform games. So the games themselves, you program to a core API, but then you can generate or compile down to different environments. So you'd build the games in Java. So that's one thing. I'm sorry if they're not Java developers. I know. But well, we'll see. Maybe we can have another abstraction layer that's not Java. But anyway, it's pretty easy Java. It's not very complex Java. So as I'll show you the code, even if you're not a super hardcore Java developer, it's pretty easy to learn. The thing about Java is that it also has a nice development environment. You know, you can use NetBeans, Eclipse, and so forth. So it's pretty good for debugging and so forth like that. And it is compatible because it is an abstraction of the Google Web Toolkit, but this API is focused solely on building video games. And it compiles to JavaScript or HTML5, just like Google Web Toolkit can also compile down and create a lightweight JavaScript HTML front end. So it's the same process. So if you're familiar with Google Web Toolkit, where you can construct your user interface and then you have it compile your Java code into JavaScript and HTML code, it's the same thing. Whereas this is creating a video game, which is a lot more fun, actually. The URL is there at the bottom. It's an open source project, code.google.com/p/4play. Now I should say the name may change. There's discussion right now about changing it to something else, and I'm not happy with what's been discussed so far, but at least for now, you can still Google it and you'll find this particular URL. Plus, I'll make sure all my slides are available afterwards so you can follow along. Okay. So, as I mentioned, it's essentially an abstraction of Google Web Toolkit, and there's implementations for specific flavors of the games. So there's just a straight Java implementation. This is actually good if you want to just test it locally very quickly. It's got a very quick startup time, so you can quickly change things and then run it locally in the Java mode, if you like, to see the changes that you're doing. And then likewise, when you're ready to deploy to the web or to the cloud, you can compile it, which is a GWT compile, a GWT compile, which then translates the Java code into JavaScript code and HTML, and then that can be deployed to an App Engine app. And because Google Web Toolkit is linked with App Engine, in the sense it's very easy to compile and deploy a Google Web Toolkit based application to the cloud with App Engine, the same thing is true for 4Play. You can compile your 4Play code down into runtime JavaScript and HTML, and then deploy that to an App Engine app. And then from then on, you can access the application from a deployed cloud or web version of your application. Now, the other implementations, Android and Flash, those are coming along, but the HTML and Java are the ones that are available. Although I heard just recently, I think last Friday, there was some initial demonstrations of the Android and Flash now fully coming online. In the first, like 2 months ago when I first started working with this, I focused mainly on the HTML5 JavaScript implementation, which is also what the Angry Birds was built, primarily because it's running in Chrome, and for now Chrome is just using HTML5. Okay. So the components of 4Play are rather straightforward. As with the typical game environment, you have a loop, so you're constantly iterating through the loop. You can extend a class over this 4play.game. It's actually 4play.core.game, actually. You have an init method, and in your init method is when you set up a number of things that you only want to do once. And typically you want to take care of this in the beginning so you don't have performance ramifications down the road. So for example, you want to load your assets. So if you have sounds, images, all these things, it's best to take care of all of the asset loading in the initialization or the init method. And then after that, you go into a loop, and every update or every paint is basically changing the view of what you're looking at. Okay? And the I/O system is straightforward as well. So that's the input-output. That's how you interact with the game. So far, it's fairly straightforward for simple interfaces. So pointers with mouse click, and so forth. Mouse, hold down, so forth. Keyboard input is also supported. I think down the road, they'll also have more advanced inputs, but for now, it's fairly straightforward. And then, of course, the asset manager. This is what you would call in your init method, where you can actually start loading up your images, sounds, and so forth. So it's all preloaded and ready to go. And then the application, once it's ready, it has all that stuff available very quickly and for a high-performance video game. Here's an example of a class called MyGame, which implements game. It has the init method, update, paint, so forth. So relatively straightforward. I'll show you the actual code of some examples shortly as well. This code is an example of the I/O system. I should say that the code right here that you're seeing is slightly out of date. It's just the pointers or the keyboard is actually now a generic event as opposed to an int. But a small detail. But the overall framework continues to evolve and get better and so forth. So if you start working with this, you'll want to expect that you'll check out the code fairly frequently and also listen or participate in the discussion group so you can hear the various changes going on. Okay. So the overall set of components for Foreplay is actually fairly straightforward. And actually, there's a fairly sophisticated layering system. So you can create a layer, and then you can attach an image to it, and then you can operate on the layer itself to manipulate the image. So if you want to do animations or rotations and so forth, you essentially work with a hierarchy of layers, and these layers can be stacked on top of each other, as with typical other types of video game systems where you're interweaving different types of sprites and components, and that's how you interact with that. And of course, that's how you're looping through your main game loop to change variables and change the interactions, and then you can do collision detection between the different objects and see if they bump into each other, things like that. Okay. This is a bit of code that shows how to handle asset management. So if you have an image, this is what you would typically call in your init method of your game to make sure that you have the image available for use later on. So let's show some more demos. Demos are fun, right? So for this, I want to go ahead and switch over to, I'm going to even do this. I'll go to Google, and I'm going to say GWT Foreplay. Now, the reason I put GWT Foreplay, because if I type in Foreplay by itself, I might get something else. So GWT Foreplay is good enough. So a cross-platform game abstraction library. Okay? And as you can see, code.google.com/p/foreplay. And there we go. It's a cross-platform game abstraction for Java, HTML5, Android, and Flash. Getting the source code is very easy. Just go ahead and, as with any Google project, check out the code. And then once you've checked out the code, you can open up the projects, the samples projects, and the core projects in Eclipse. And that's what I've done here. So for example, actually, my workspace is kind of a mess because I put a bunch of demos that are different. But I can show you like very simply like what some of the applications are. So for example, Hello Game Java. Now I can just press the Run button right here, and this will fire up the Java implementation of this game. Although the actual gameplay is defined separately. So as you can see, this is a very, very simple game, but it's meant as an example of how to intercept the mouse click events, create a new, this is a P object, Arbeja, I think, Arbeja, and do some rotation with it. So if you understand how to do this, you're already getting familiar with how to do that. And then, of course, here's the core. There's my P. So I have actual Java code that I can get the image. I can do translations. So I'm working with the actual layer that I've attached an image to. And I'm also responding to a click of the mouse. And then I'm essentially doing that. And then As you can see here, I'm defining a rotation and the angle. So this is a sample that you can download and very quickly bring it up into Eclipse and play with it and see how it works. And actually, I recommend playing with it because that's really the easiest way to learn. I found learning in that manner makes it quite easy. So yeah. So that's a very simple example. Let me show you another one that has keyboard interaction. Oh, and don't worry about this. This particular build, or this iteration of ForPlay, the Android stuff was broken. So but that's okay. I wasn't worried about that then. Let's take a look at another simple game. Now, as you can see, every time I start up the game very quickly, it's fast. So I can interact with it fairly quickly and easily. Actually, there's a little bit of a bug there. The refresh is not working. Anyway, it'll get fixed. And then I can actually intercept the keyboard, and it's bouncing. So that's like a little, typical game. Again, this game shows other concepts of how to interact with the different features. Okay. And the other one here, I'll just show it to you real quickly. So I learned ForPlay essentially by looking at these different samples and comparing and contrasting. And this one is kind of neat because you can see the physics in action. So it's actually a lot of fun to kind of play around with the technology and see how the physics interacts very easily. And if you're curious about how the physics works, you can go in here and maybe play around with it. So here's a little bit of code where I'm going to change the gravity. And say I want to change it to something a little bit different, just to kind of observe the cause and effect. So I've changed the value from 10 down to 1. And as you can see, it's very slow. So I found also that working with this environment, because the iteration is so fast, I can quickly make a change and then run it and test it. I find that it's almost a bit of an art where you can kind of tweak little adjustments just to get the gameplay exactly the way you like it. And that I found to be a lot of fun. So it's kind of more of like an art, I would say, than pure programming. Okay, so that was obviously too slow. Let's try something faster. How about that? See what it looks like just for fun. So we now have a value of 50. Oh yeah, there we go. And it's cool because in the sense it can handle a lot of different interactions. And then when I run this on the browser, it still actually works just the same. Okay? So at this point, let me go ahead and change. Now, pardon me, I'm just going to do a little bit of a quick change on my workspace here because I have some other stuff that I've played around with. I just want to show you. So far, is it okay? Is it interesting? Pretty straightforward stuff? Yeah. So let's see, here's my peas sample. The one thing that I found fun was to also play around with the P world. Actually, I did this one, but if I also interact with the core entities a bit. Sorry, my font got big all of a sudden. So here's, just for fun, you can kind of see what I'm doing here. Yeah. Oh, come on, wake up. And this one. Oh, maybe it's the other one. I set it up really quickly just before the talk. Okay, so now let's go ahead and run this just for fun. And to be honest, when I was learning how to use this framework, I ended up just playing with it just to see what happens when I change little bits of things. And that's how I learned how to use it, just to kind of see for fun. So there you go. There's a slight different change now. We got our little Chrome things, and we got a nice little app engine flying there. So anyway, as I was playing with the app engine, with the samples, it actually inspired me to create a game, a different game entirely. So I'll show that game, but I won't show it right now. I'll show it towards the end of the presentation. But anyway, it's kind of fun stuff. So anyway, just getting back to the slides, the cool thing about, and this is definitely I would say one of the most cool things about it, is that it has the capability of being very cross-platform, but you can program to a single core model. So you don't have to write a whole bunch of different code for the different environments. So in my case, I kept the same init loop, the play loop, I kept the same init code, and then when I just run like a little stub that starts it, it actually kicks off the Java version, or I can actually run it with the HTML web version. And I can actually run it locally. It's a little bit slower, but I can show it maybe towards the end if we have more time. And then I can deploy it. And the GWT compile is when I can actually take the Java code, turn it into something that I can deploy and send it off to App Engine. So the physics engine, I think, deserves a little bit of attention. The story on this is it's based off of proven open source technologies. So Box2D was the original C++ 2D physics engine written by Eric Kato. And then JBox2D was a Java implementation of that same physics engine. And then the GWT Box2D was the port for GWT from Java to JavaScript of the same technology. So we went originally from C++ to Java and then to JavaScript, which is cool because in the Java side, we're using the JBox2D when I'm running locally, and then as you'll see when I run it in the web, I'm just using the same library, but now it's the JavaScript version for GWT Box2D. There's some other benefits of GWT abstraction. Because it's based essentially on GWT, it's very efficient. So GWT has been around for a number of years, and the focus has been for application efficiency, high performance, interactivity in the application, applications that work well with every browser. Essentially, the code is compiled per browser. It can sense what environment it is and have the best maximum performance. The result code is also heavily obfuscated, so it's essentially secure. You don't have to worry about that. The compiled code is also compacted very small, so it gives you faster load times. So you may think that you have a lot of complex Java code, but in the final result, when it creates the final JavaScript, it's really not that large, and it can be sent up to deploy in the cloud. Okay. It also takes care of caching, so there's not unnecessary network round trips and so forth. It also, because GWT by itself takes advantage of HTML5, it uses the new HTML elements, 2D canvas, it has audio, video, 3D canvas or WebGL. So basically it's taking advantage of the latest technologies for nice, rich interactivity, as well as CSS3, for example, to have like a nice, rich, interactive environment for your games. And same is true for Google Web Toolkit. You want a nice, rich AJAX environment for your web applications. So here's an example of me kind of taking the sample and then modifying it a little bit more. And what I did is I created a little game, and I'll just show it to you really quickly. And all I did was, it was as simple as just changing a bit of some code here. There we go. So there we go. Now I can fly my little app engine, and I can actually eat the little balloons. And I can turn around and go for some other ones, and I keep score. Oops. I'm just not very good at it, that's all. Oh, I'm really bad. There we go. So you get the idea. So anyway, I created this using the same samples, but I took the same cloud image, and I also, you notice the little app engine? It's rotating the engine and stuff. That was Photoshop. So I basically create the animation, and then as I'm iterating, I transform, or I change the image. So I rotate and click the image. So pretty standard video game stuff. One thing that is different is that when I run this on the web, I have my own personal setting where, because I'm a pilot, I press the down to go up, the stick to go up, and vice versa. But when I'm running in Java mode, I don't have my profile set. So you get the idea. don't worry about that. That's a little thing because I'm making an RPC call, which in this environment is not working. So that's my game as I'm running it locally. Let me go ahead and show you the version of it. Oh, here we go. So this is a deployed game, and as you can see, it's very simple. I haven't created a nice, pretty like front end like you see with Angry Birds. But one thing I did do is I created the ability to save the scores to an App Engine backend. It's not a backend, but it's just basically a service that handles HTML posts, and it sends the scores. And I also allow users to log in. And so as I've been playing it, I've created my own set of scores based on the game. So let's go ahead and go back, and this time we'll launch the game. And as I've been working on it a little bit more, and this is just like a side project for fun, I have the same game now, but now I'm running entirely within the browser. And this time I can control it better because I know which way is up and down and so forth. Oops, or maybe not. So that noise, that bang, is actually a book smacking on the desk that I recorded. So you get the idea. Let's see. And obviously I can make this game more complex, where I can have, like, you know, different points for the balloons. And but for me, for now, I just figured I would start with getting the mechanics and kind of understanding how I can do the game loop and how I can handle keyboard interactions and so forth. But yeah, it's actually very straightforward. There we go. It's very straightforward, by which I can then start to customize, because at this point I can add new things. So instead of just balloons, I could add other enemy airplanes, and I could fire missiles. That's all just a matter of work that takes time to create missiles, but they're just, you know, same layers with, you know, images attached to them and so forth. So there's nothing complex about it. And also, if I go back to my scorecard, so 1500 was what I had. So yeah, I've been having various 1500s across the board for my application. So anyway, that's pretty much it that I wanted to show you oops, let's see, here we go, I had it, there we go. So let me explain a little bit more about the architecture. The game assets, I actually use Google Storage because I wanted to see how Google Storage works as an asset repository. So the sounds, the images, everything, I actually just fetch directly from my cloud in Google Storage and load them up into my core game there. And then, as you saw earlier, my game scores, I'm just using the RPC mechanism built in to the foreplay. So there's a little example of how you can create a servlet that will respond to the, you know, any kind of HTML posts or GET. And I essentially send up a JSON post with my score, and it has also my user information. And then I just, in my case, it's a very simple, I just put the username and the score and continue to add to my overall set of high scores. But yeah, that's it. I just had fun, and I figured I would share that and just hopefully get you guys interested in trying it out. So as you can see, just for a quick summary, it's open source, cross-platform, abstraction layer. The core gaming logic is platform agnostic, so you can write all the play loop, the initialization, the I/O interaction. It's all agnostic. Let's see. It is Java, so apologies to any non-Java developers, but I would say it's fairly easy Java. There's nothing terribly complex about it. So if you can build some classes, implement, you know, particular interfaces, you're fine. And you can use the Eclipse plugin for the Google Eclipse plugin for actually building the application and testing it locally. Oh, one thing I didn't show, I probably won't show it, but you can run the application in the browser locally as well. It does require a little bit longer startup time. I tend to like to just build it and run it in Java first because it's so quick. And then I do a compile to HTML, make sure it runs locally, and then I deploy it to my cloud deployment environment. So your assignment is to go download or check out the code for foreplay and play around with the samples, do what I did, just kind of have fun with the physics, have fun with the images, have fun with the interaction, and try building your own game. And if you want, you're welcome to join this development community and submit samples. They're looking for samples. I'll probably submit this as one of the samples as well. I just need to clean up the code a little bit, but it'll be there. So anyway, thank you very much. I'd like to go ahead and if you have questions, I'll make sure to tweet my slides for this talk as well. And otherwise, muchas gracias. Thank you.
Is there any plans of adding WebSockets to the API?
I think there might have been some discussion about that. It's all abstracted though. It's essentially through the RPC mechanism. Right now, yeah, I don't believe it's using that. You could quickly look at the discussion group and scan for WebSockets to see if anyone has brought it up. I don't recall exactly, but yeah. I'm also, I should say, I'm not one of the core developers on 4Play. I'm kind of an end user, but I think my point is that it was so easy for me just to build some simple, fun stuff that really anyone here could, if you're a developer, you can get familiar with it pretty easily as well. So yeah. Question up there.
So what about 3D games?
I'm sorry, what? 3D, yeah. So right now it's 2D. I'm not sure of any plans for 3D for this particular framework yet, but that's a valid question. But I think for now it's definitely a kind of a retro game. The Angry Birds has a retro feel. The physics is not so retro because I never recall playing Donkey Kong with real physics. But yeah. Any other questions? Cool. Well, I'll be outside if you want to ask any other questions. And anyway, thank you for attending the talk. I hope you guys enjoyed it. Okay. Okay.